Welcome back, grade 12s. In this video, we're also continuing to look at examples where we work with the net force and the changing momentum, time, and velocity. So this is video number 2. So I call this example 2. A 3 kilogram block slides along a horizontal frictionless path AB at a constant velocity of 1.5 meters per second. So here I'm going to represent the AB part, which is frictionless. And this block is busy moving in that direction at a velocity of 1.5 meters per second. Passes over a small rough patch BC. So here you've got small rough patch BC. The box then continues in its original direction along a frictionless path CD at a constant velocity of 1 meters per second. So this thing was slowed down a little bit. So the final velocity is 1 meter per second. So here the net force was acting in that direction. This is F net direction because the friction would be the net force. There will be no other forces acting along the horizontal direction on the block. Question 1 asked us to determine the change in momentum of the box. So the change in momentum is the mass of the box times the change in velocity, which is Vf minus Vi. Now the box continues moving in this direction towards the right according to my sketch. So it's 3 times 1 minus 1.5. In this case, we see that the change in momentum is a negative value. It means that the change in momentum is backwards, opposite to the direction of motion. So it's kilograms meters per second. This change in momentum is a vector quantity, so we need to write it as a positive number with the direction included. I'm going to say backwards, but you can also say that it is in the opposite direction to motion. Part B asks us to use a vector diagram to illustrate the relationship between the initial momentum and the final momentum and the change in momentum. So the final momentum is in this direction. No, I'm playing now. The final momentum is not in that direction. The final momentum is still in that direction. PF. The initial momentum is in this direction. But the initial momentum is bigger than the final momentum. The final momentum is this 1 times 3, so it's 3 kilograms meters per second. And the initial momentum is 3 times 1.5, which is 4.5. But we subtract the initial momentum from the final momentum, which is the 4.5 initial momentum, subtracted from the 3 kilogram meters per second. Therefore, you see that the change in momentum, which we draw from the tail of the final momentum to the head of the initial momentum is towards the left. Okay. How will F net, Vf, and delta P be effective if the rough patch is made rougher? If the rough patch is made rougher, the F net would be increased. So let's answer that question here. Number C, if the rough patch is made rougher, it means that the net force will increase. If the net force is increased in opposite direction to motion, we can say it's the negative direction. Then, because the delta P is directly proportional to net force, the delta P will increase in the negative direction. And in that case, what will happen to Vf? It will decrease in the negative direction. Sorry, it will decrease in the positive direction. Right, so because the velocity, the net force is in the opposite direction to motion, the final velocity will decrease even though the delta P increases in the negative direction. So if I need to explain it properly, when the box is sliding over the rough patch, then, and the time is kept constant, that is the main thing there, the time is kept constant. A larger frictional force, which is your net force, in the reverse direction will cause a larger negative change in momentum and a larger change in velocity, but the final velocity will be decreased.